So, hello students, this is the third lecture of solid mechanics PCME 502, and as I discussed earlier in the previous class that today we are going to discuss about the relation between resilience and toughness. So as you know that the resilience is the property of a material, let us write over here, that is the resilience. So it is a property of a material that enables to resist shock and impact by absorbing strain energy without permanent deformation. So this is very important, that it enables resist shock and impact by absorbing strain energy without permanent deformation. Okay, so over here one important parameter that comes into the picture, strain energy. In short form I am writing SE, okay, without permanent deformation. Okay, so resilience is measured in terms of strain energy or SE, which I have already written, per unit volume, which is given by, what is the numerical expression? So SE equal to half stress into strain value. Okay, so if it is a triangular in shape, so what is the area under the triangle? That is half into the base into the height. So in a stress strain curve, if I show you, so in figure 1, if you can see, in figure 1, that is linear load versus deflection plot. So strain energy, which is the area in pink color, so it is the area under the straight line curve or linear curve, that is strain energy. So the area under this curve is half into stress into strain. On the other hand, we can say, so for load versus deflection curve as shown in figure 1, the area under the inclined line is called as strain energy. Okay, so in this load versus deflection curve, as you can see, so the area under this is called as the strain energy, obviously. And what about the toughness? If I am talking about toughness, so toughness as shown in figure 2 in stress strain diagram. So over here you can see another area which is under the curve, that is the measure of the toughness. It is the ability of a material to absorb energy. If I write, it is the ability to absorb energy during both elastic and inelastic deformation. Okay, this is very important. It is not only elastic but also inelastic deformation. The measure of toughness is the area within the stress strain diagram as it is shown in figure 2, including the inelastically deformed zone. That means a part of this particular curve, for example from the origin to suppose up to this particular point, it is elastic or linear in nature, and after that it becomes inelastic property. It is showing inelastic property. So both elastic and inelastic property, that is shown over here. So it includes the inelastically deformed zone also, as shown in figure 2. The difference between the resilience and toughness may be noted from figure 1 and figure 2. So clearly you can see that what is the difference between resilience and toughness. So in resilience it is within the elastic zone, and for toughness it is both in elastic and inelastic zone. And in both the cases, either we take the load versus deflection curve, especially for the resilience, and in case of toughness the measurement depends on the stress strain value. Okay, and strain energy under this curve, it is the amount of absorbed energy, that is the measure of resilience in case of figure 1 and toughness in case of figure 2. So that's all for today's short class. This was your lecture 3 on the concept of relation between resilience and toughness. See you soon for the next class, and the next class we are going to discuss about the principles of strain measurements, especially the mathematical preliminaries and all. Okay, till then, goodbye, stay well, study well, see you soon.